Hello, everybody. I'm very glad to be the moderator today of this second event that is undertaken under the series of webinar of the project Climate Change in Agriculture, CLICHA, an Erasmus Plus KA2 action, organized in this pandemic issues. So we will also organize such other events. So please follow us on our website or Facebook page to be aware of all the events that will be organized through this period. Quickly about this second event. So the second webinar actually will be dealing about the impacts of climate change, this issue of growing concern on coastal area mainly. So the presentation will afterward depict on the effects, namely the drastic change in the climatic condition, the sea intrusion, etc., that could affect either directly or indirectly such a vulnerable area, which are the coastal area. So we will have in total 5 presentations of about 10 minutes, and after all, we will devote the session for the debate and question response. So I wish that this webinar will be fruitful for all of us. Madame Jemila, if you want, the floor is yours. Madame Jemila? Madame Jemila?
ميكرو مسكر نتاعها.
تسمعوا فيا؟
Oui, maintenant, oui.
Maintenant, mais vous ne voyez rien et je ne trouve rien. Bon, j'ai des problèmes avec la présentation. Maintenant, est-ce que vous voyez la présentation?
Non, pas encore.
Je vous la partage, madame.
Je préfère نعمل partage, mais إن شاء الله تختفى واش نجرب سينو عملها انت.
تستيتها مقبلي كم شيء.
تيست وانا تيستي قولي مشيت وتو هاي ما بيجي شيء. في بالي ننتظر المشكل. اوكي. واو. Je vais faire partager quoi.
Ce sont les problèmes du direct, c'est pas grave.
Ok, juste une minute. Hein. Oh. Oh là là. Ok. Non, ma habche.
Je partage. Bon,
Partage, Leïla.
Tout de suite, ok.
Si je vois, hein. Oui, Leïla, partage.
Oui,
ok. تحطوا plein écran, c'est bon.
Oui. Voilà.
Si, Leïla.
Okay.
Hello, everybody. I will try to speak quickly about the risks and aggravation factors that may affect water resources availability in coastal area. Next slide, please. I grouped or I classified the factors that may affect water resources in coastal area in two types. Direct related effect that are quantity and quality. The quantity is due to decrease in recharge and mainly and increase of runoff outside the area related to runoff and rainfall change and storms, and the quality degradation due to salinization and all other forms of pollution. Also, there is some indirect effects that are related to agriculture, industry, and tourism activity intensification along coastal area, because that may accelerate the land degradation and then accelerate also the runoff and the loss of surface water. That also may contaminate the water resources and increase groundwater withdrawal. The effects and the factors may be local factors related directly to the climatic parameter inside the area, such as sea level rise, temperature increase, or rainfall decrease, or storm events that may become more frequent. But also the climatic condition or the climatic change in inland area inside the country can affect the coastal area, because the population will move and to the coast area, and the tourism will be more and more developed, and this will need more to mobilize more water. Next slide, please. As you may know, the coastal area is attractive zones because of their rich resources and their ambient conditions. And as this may be traduced by an increase in population and also by an increase in water demand as well as food demands. According to FAO study, to this study, as you can see from these graphics, the population in the world should be increased drastically from 1,000 to in the next three decades. Next slide. If we can resume the effects on water resources availability, we can say for surface water resources, we can observe a reduction that is related from one side to the scarcity of rainfall, but another side of the storms that became more and more frequent on coastal area. Then this will reduce the surface water storage on land and in soil. For groundwater also, we will this climate change will increase pressure on groundwater resources, and the aquifer will be directly and indirectly influenced by climate change. Next slide. The FAO classified and identified all the factors that may influence the coastal aquifers that are mainly related to coastal process, erosion and shoreline retreat, storm, and tsunami. To rising water demand, domestic water consumption will be higher, and agriculture, tourism, industry water demand will increase also. For other factors are related to the environmental change, like sea level rise. We will see its impacts on the availability of fresh water, change in nature recharge that are directly related to precipitation and evapotranspiration. Human activities along the coastal area, river and estuary modification and mainly due to flooding, increase of salinity, sedimentation, and erosion. The main observed effects are saltwater intrusion may be accelerated or increased, groundwater resources deteriorated. We can also observe salt damage, mainly in ecosystem, crops, and also land subsidency. Like countermeasures, we should better manage the water abstraction, control the water demand, improve the aquifer recharge by adequate surface and management, and also develop and introduce well-adapted engineering approaches. Next slide, please, Leila. I will try to analyze some key climatic change factors and their impacts on on water resources availability in coastal area. The IPCC defined the vulnerability of coastal aquifer system to salinization as the degree to which it is susceptible to and unable to cope with the adverse effect of sea level rise or ground extraction. Next slide. As you may know, when in nature condition, there is an equilibrium between saltwater, seawater, and saltwater and fresh water inland. But if the seawater will rise, this equilibrium will be displaced inland, and we will have more of we will have more salinization inland, and the aquifer will be contaminated by salt, and we will get a reduction of fresh water in coastal area. Then the sea level rise will also contaminate or contribute in salinization of aquifers. Next slide. Here also another problem that may be induced by sea level rise is the subsidence. That means that may present for building stability and for cities population and all population growth and circulation. Please, next slide. Also, with the climate change, mainly temperature, we will have high water demand that will will increase freshwater pumping rate, and when the wells are near the shoreline, we will have this will contribute to salt intrusion by the phenomena of upconing, well known on the coastal area. Next slide, please. The temperature may affect also the evapotranspiration, and this will affect the increase the water demand for irrigation, and also increase the demand of fresh water for citizens. And this one side. For another side, the temperature may induce more storm events in the coastal area. Next slide. Also, according to the finding of climate change, rainfall may on coastal area may decrease, and this will induce an increase of climate deficit, and again this will be traduced by an increase of water demand for irrigation and a decrease of recharge rate. That means we will get less and less fresh water coming into aquifers. Next slide. Because all these factors and agriculture active intensification, population growth, citizen city extension, we will see and we will assist as land, we will get land cover degradation on coastal area. And this with runoff, will induce an acceleration or an increase of the runoff and more loss of surface water from land to the sea. And then we will observe a reduction of surface water storage inland and also an increase of groundwater pumping to face water shortage. Next slide. As conclusion, I can say that the factors that affect water resources availability in coastal land are interdependent and some are directly related to climatic change and other are related to anthropogenic forcing factors. Okay, and all of these factors are disfavorable for water storage and may induce water resources shortage and degradation. Thank you.
So thank you very much, Madam Jamila, for having respected the time and mainly for this introduction and explanation about the coastal area and the climate change effect. So now after, Dorsaf will present her work.
Alors, j'arrive pas à partager l'écran. Madame Leila?
Oui, Faye, would you please give her access to share her screen, please?
Just a moment to find the name.
Dorsaf Fayesh.
Can you, okay. Now is it fine?
Yes.
Can you share?
Moment.
Ça va, Dorsaf, non?
Non, pas encore.
Si, si, c'est bon, c'est bon. Ah, ça
C'est
vient.
bon? Vous voyez là?
Oui, juste vous le mettez en plein écran et c'est bon.
Good morning, everybody. My presentation entitled Climate Variability and its Effect on Normalized Difference Vegetation Index using the remote sensing in semi-arid area. In introduction, Gabes is the only coastal oasis in the Mediterranean basin with a palm grove of 300,000 date palms and a large diversity of fruit trees, which make the agricultural identity of the region. In the last decades, and unfortunately, the oasis environments have begun to change and undergo multiform interactions such as pollution and industrialization, increasing scarcity of natural water resources, and serious losses to agriculture, which generate climate variability. Despite the many threats to the Gabes oasis, no scientific research has been carried out to to investigate the sensitivity of vegetation growing to climate variability in local environment conditions, so as to address a better environment management. Therefore, the main objective of this work is to study the variability of rainfall and land surface temperature to come to a better understanding of how these two parameters act together to affect the vegetation growth on the basis of normalized difference vegetation index data extracted from Landsat thematic mapper. Materials and methods. Our study area is located in the southeast of Tunisia and it's characterized by a semi-arid climate. For the used data, we have data and only station with less than 25% of missing data over the period 1975 to 2015 have been selected. The selection allowed us to select 22 stations. Homogeneity test and estimated of the missing data in the record periods were done according to the regional vector method using hydro-access model developed by the Regional Institute of Development. Then we have used the remote sensing data, and the data series includes images recorded from two different sensors of the same observation platform, Landsat, over a period of 30 years. In the method, we have used the chronological graphic method of information processing, or the matrix Bertin. It's an analytical method based on statistical analysis and on graphical spatial representation of results. In the matrix, 5 stations belong to different sectors are selected. The stations are Motouya, Gibbs SM, Matmata Ancienne, Ranouch, and Merth station. Finally, the normalized difference vegetation index, or the NDVI, is calculated as a ratio of the difference between the near infrared and visible reflectance values to the sum of total reflectance. Then, the land surface temperature was obtained using the remote sensing on the thermal band information and the GIS software. Processing in ArcGIS software, different mathematical algorithms may be used to measure land surface temperature. And we should apply algorithm 1 when the images are from Landsat 5 and 7. And in the case, only band 6 was used to retrieve the land surface temperature using the spectral radiance model. And we have to apply algorithm when the images are from Landsat 8. And in the case, 2 thermal bands were used to retrieve the land surface temperature using the split window method, and there are band 10 and 12. In results, the figure represents the matrix Bertin. We have to note that dark blue, light blue, green, yellow, and red indicate respectively very wet, normal, dry, and very dry year. Based on visual observation, it can be inference to an alternation of dry and wet periods, strong variability, a preponderance on deficient fronts, on rainy fronts over the 2 last decades, and finally, increasing of the absolute value of standard pluviometric index in dry years. We conclude then, it can be concluded that the study area is subject to an increasingly severe aridity. Then, the results of determination of NDVI allow to obtain these maps. In remote sensing, these results can be described in terms of the evolution of NDVI pixel number, that the value is less than 0.15 and that represent an urban area, and NDVI with NDVI more than 0.15, and it represents the pixel when we have a vegetative area. The analysis of the NDVI variation from 1980 to 2015 shows that the vegetative area has decreased by 74% from 1987 to 2003. Then it has multiplied 30 times from 2003 to 2015. Let's now study the impact of climate change on NDVI. In the section, the linear regression is used to analyze the relationship between NDVI and rainfall, then between the NDVI and land surface temperature. In all cases, we show that a linear regression with a positive correlation coefficient higher than 0.8 exists between NDVI and rainfall. And we note that the beta coefficient is insignificantly recorded to the t-test. Thus, rainfall does not significantly predict NDVI, despite the high correlation noted. Then the results of determination of land surface temperature are showed in this figure, as you see, and we can conclude that the LST has increased during the period from 1988 to 2015. And the relationship is expressed by a strong negative correlation that ranging from 0.7 to 0.9 with a beta coefficient ranging from 0.086 to 0.017. In discussion, despite adverse climatic changes to vegetation growth, we mean the decrease of rainfall, the photosynthetic activity increased. So how can explain these results, taking into account the results of t-test of sensitivity? The results led to think that other local factors intervene and affect the NDVI, which can be the farming practice of farmers. So we have to verify the hypothesis. From the results from this hypothesis, we have analyzed the evolution of the area of irrigated perimeters from 1995 to 2015, and we show an increase of about 50% between 2003 and 2015 that correspond to the growth of pixel numbers of NDVI more than 0.15. In the same period, the rain feed, so the cereals in yellow curve, feed has been filled by 64%. Then decrease can be a result of adoption of a new practice of farmers, which consisted in the extension of irrigated area. Moreover, the exploited volumes of deep groundwater for irrigation recorded a growth of about 17.5% between 2000 and 2018, and the land surface temperature decreases with the growth vegetation. In fact, if the water supplies are insufficient in soil, the evapotranspiration increase at the land surface temperature. So in conclusion, GABIS is characterized by decreasing of rainfall during the 14 years series from 1976 to 2015, while the land surface temperature has decreased. In annual scales, results of linear regression have shown a positive relationship between NDVI and rainfall, while the relationship was negative between NDVI and land surface temperature. Affected by this climate trends, the growth vegetation has been decreased by over 70% between 1987 and 2015. On the other hand, an increase of this area has been observed since 2003 in spite of a decrease of rainfall. This fact led to think that practice of irrigated farming is local factor that affects the relationship between NDVI and rainfall in GABIS. This was proved by the analysis of the evolution of the irrigated area and exploited volumes of deep groundwater. These Foundox results have clearly described the relationships between atmosphere, soil, vegetation system of the study area and confirm that the physiology of the plants is affected concurrently by land surface temperature and rainfall in the same time. This system cannot be immune to the interactions with other environment compounds. Thus, irrigation supplies is able to limiting the water stress. Thus, and growth vegetation may be observed, from where the land surface temperature and rainfall can be considered as indicators to monitoring growth vegetation and particular interest should be accorded to irrigation management in GABS. Thank you for attention.
Thank you very much, Dorsaf, for the presentation of your case study of GABS. So through your presentation, we can easily notice the importance of the tools that you use, which are the normalized difference vegetation index. And we can see its report on the effects of climate change, such as rainfall, etc. Many thanks. So after that, we will have the presentation of Madame Najla. Madame Najla?
Oui, oui, je suis là.
Okay.
Alors, I have to share my screen, so
Yes.
Dorsaf.
Yeah.
Okay, it's okay.
It's okay.
Alors.
Okay.
Good afternoon, everyone. I'm Najla Hrigatletli, Professor of Hydraulic and Modelization at INAT. I want to present you a simple introduction to coastal erosion under climate change. I begin with the definition of climate change. Second NASA definition, climate change is a broad range of global phenomena created predominantly by burning fossil fuels. And these phenomena include the increased temperature trends, but also changes such as sea level rises, ice mass loss, shifts in flower, plant blooming, and extreme weather events. And here we are interested by especially sea level rise. So climate change is the global phenomenon of climate transformation, characterized by the changes in the usual climate of the planet, especially temperature, precipitation, and wind. And the principal causes of these changes are the human activities. So as a consequence of these changes, the sustainability of the planet's ecosystems is under threat, as well as the future of humankind and the stability of the global economy. I want to point the difference between climate change and global warming. According to the US Geological Survey, global warming is just one aspect of climate change. In fact, global warming refers only to the Earth's rising surface temperature, while climate change includes warming and the side effects of warming, like melting glacier, heavier rainstorms, or more frequent drought. Ultimately, this means that global warming is one side of the much larger problem of human-caused climate change. And here we are interested especially on global warming. I want to present you some statistic for climate projection in Tunisia. I find them in a study conducted by the USAID for Tunisia. We can see that the effect of climate change are on many fields: agriculture, infrastructure, tourism, health, governance. But I especially focus on the fact that by 2050, the temperature will increase in Tunisia from 0.7 to 2.6 degrees. And this will have come as a consequence a rise in sea levels from 3 centimeters, between 3 centimeters and 6.1 centimeters. And so all this will cause coastal erosion. What's coastal erosion? Coastal erosion or shoreline retreat is the loss of coastal lands due to the net removal of sediment from the shoreline. Coastal erosion can be either a rapid onset hazard, which occurs very quickly on a period of days or weeks, or a slow onset hazard, which occurs over many years or decades or centuries. And the cause of coastal erosion are both natural or anthropogenic, so man-made. The natural causes are mainly rising sea levels due to climate change, melting ice at the poles, and the greenhouse effect. Wind erosion, which causes the disappearance of the coastal sediment stock flowing the onset of the wind. And another cause would be the exceptional storms and swells assault, which cause sediment to disappear. The man-made disturbances cause the cutting off of the natural supply of sediment to the beach. For example, the construction of coastal structures such as breakwaters, harbors, and seawalls can lead to changes in coastal sediment and can also strongly influence the propensity of landforms to erode. Moreover, the construction of dams leads to the cutting off of a major source of sediment supply to the beaches. The removal of sediments from the coastal system by dredging or sand mining, or a reduction in the supply of sediment by the regulation of rivers can cause coastal erosion. At larger scales, natural and human-induced climate change can modulate the likelihood and rate of coastal erosion. Here, I found a study done in Tunisia, in the Gulf of Hammamet. This study was carried until 2019, and we can see on the first line, which represents photo aerial view, we can see that the several shoreline erosion trend between 1960 and 2019. Then on the second line, we can note the decrease in the width of the beaches and the growth of the urban area, which are represented by white zones, against agriculture fields represented here by dark zones. And in fine, the third line, it's a zoom of a beach in Hammamet between 2014 and 2018. And you can see that in the same place, there is no matter on 4 years, there is no beach. In this photo, on these figures, we see some white arrows. They represent construction, and they constitute a reference for the photo. On the same zone, the Gulf of Hammamet, here the study shows that we can see that the shore has retreated by almost half a kilometer since 1997. All this distribution, all this erosion are due to climate change and to sea level rise. Now, how to quantify the coastal line response to sea level rise? The most widely cited method of quantifying the response of a shore to rising sea levels is known as the Bern rule. It's a simple rule as we will see it. This rule will be developed to describe the behavior of sandy coast with no cliff or shore platform. And it assumes that average equilibrium beach profile does not change, but does translate up with the level sea. So there is an equilibrium on the quantity of sand on the beach. Only this quantity of sand will be translated from the shoreline. This rise in beach surface requires sand, which is assumed to be eroded from the upper beach and deposited on the lower beach. Thus, as the profile rises with sea level, it also translated landward, causing shoreline retreat. We note that despite the erosion of the upper beach, no sand is actually lost. It simply translates a small distance down the beach. There's always an equilibrium on the quantity of the sand present in the shoreline. Alors, the Bern rule formula, the mathematical formula of the Bern rule, give that the shoreline recession is equal to the ratio between the product of sea level rise by the horizontal length over the total depth. As we see it on this figure, it's as there is always an equilibrium of the quantity of sand, so the sample trigonometric operation give us the quantity of the sample quantity of shoreline recession. But we have to note that Bern rule has been the subject of some debate and criticism, but it's still generally supported. Although this rule does not represent long-shore transport and restricted their study to sites where there could be neglected. So with the Bern rule, don't takes account of the long-shore transport. It calculates only the transversal transport. Another constraint on the range of applicability of the Bern rule results from its assumptions that the shore profile is entirely beach and loses no sediment. If the shore profile is composed of both beach and rock, the rock element of such composite shores complicates its behavior because it can only erode, not accrete, and it's likely to contain material that is lost as fine sediment. In addition, being poorly erosive and relatively hard, it will have a different equilibrium profile to that of the beach and will take longer to achieve it. So, Bern formula is a simple formula, mathematical formula. Its domain of applicability is only sand beach. It don't takes account of long transport, but it gives us an idea about the shoreline recession. And thank you. It's all for me.
Thanks very much, Madam Najla, for your presentation about the introduction of the coastal erosion and climate change, and for your second part about the quantification of the coastline response to sea water level. So now, please, Salsabil and Fatma will present to you the groundwater vulnerability to seawater intrusion under future climate change scenario and the case of Awisha Al-Milh coastal aquifer. Please. Salsabil et Fatma Travelsi.
Hello everybody. Salsabil will share her screen. Salsabil.
Do you see my screen?
Yes.
Okay. This study entitled Groundwater Vulnerability to Seawater Intrusion under Future Climate Change Scenario, case of Ghar al-Milh Coastal Aquifer. So the general context, as you all know, is based on climate change. The main factors of climate change is the increase of temperature that causes the sea level rise and the decrease of precipitation added to human activities, increase of overpumping, increase of urbanization and the overpumping that causes the decrease of groundwater recharge and the elevation of groundwater discharge. All these factors combined together in a coastal aquifer, it led to the increase of seawater intrusion. So the study area is located in the northeastern of Tunisia, the Ghar al-Milh basin. It's limited in the east by the Mediterranean Sea, the Ghar al-Milh lagoon, and the Sibkha of Sidi Ali al-Makki. This area belongs to the semi-arid and sub-humid bioclimatic floors with a mild winter and an average temperature about 18 degrees. The annual average of precipitation is 514 millimeters per year, and the annual average of evaporation is 1,300 millimeters per year. This region is of an agricultural and industrial vocation. The irrigated perimeter exceed 5,000 hectares, and they are irrigated by surface water. The phreatic coastal aquifer of Ghar al-Milh is mainly composed of sandy clay formation belonging to the recent Quaternary and the sandstone of the Upper Pliocene Porto Farina. The principal methodology used here is, first of all, the data collection. We used climatic data, hydrogeological data, historical hydrochemical data, and topographic data and hydrological data. We added to this field data to be able to implement a database management system that helped to do a numerical modeling of groundwater flow using USGS mode flow to be able to simulate the groundwater level. And then we mapped the seawater intrusion vulnerability using GIS to be able to calculate the GALDIT vulnerability index. Then we characterized the seawater intrusion under climate change scenarios. Here I'm explaining a little bit the gilded vulnerability index. In fact, it's an equation of it's a sum of 6 layers. G for groundwater occurrence, A for aquifer hydraulic conductivity, L for the groundwater level, D for distance from the shore, I for the impact of existing seawater intrusion status, and T for the aquifer thickness. I'm highlighting here the 2 layers in red colors, the L and the I layers. I have to say that these layers are considering dependent layers to climate factors. Other layers are static. First, our first result here is the simulation of the groundwater level. So the simulated groundwater level under wet and dry climate conditions are shown here. We noticed that the water table varies between 2 and 16 meters below the ground surface in the inland area, and is less than 2 meters below the ground surface in the coastal area, where groundwater discharges into the Gharm Malh lagoon. In many parts of the aquifer, the groundwater level is close to the ground surface, and water intake areas are located along the coastal line, where the groundwater level may often fall below the sea level. Here, for example, near the Gharm Malh lagoon. Here I'm showing the gilded data layers. We prepared them using the available raw data. We classified the data layers into 5 bands, in which the red to green color palette displays the area with high to low contribution of data layers in the value of vulnerability to seawater intrusion. The hydraulic conductivity map, in the hydraulic conductivity map, we can remark that the moderate to high values are in the low half of the plane, while the higher values are close to the shoreline of Inusha. Here, for the groundwater level, the map shows that the areas near the shoreline are vulnerable to seawater intrusion. The impact of existing saltwater intrusion map displays the high and relatively high west part of the plain. These layer cadres in red are dynamic layers, as I said above, and are considered as time variant layers. So to be able to examine the future climate change impact on seawater intrusion, we use the climate change knowledge portal for the Mediterranean area, and we remarked that a general average increase of 1.5 to 2 degrees Celsius of temperature is predicted. And here we remarked also that the highest increase is during the period summer. Combining the gilded results and the simulation results, we've been able to show several 2 scenarios. So here I show the gilded vulnerability index in 2020 in wet season and dry season, and the gilded vulnerability index scenario 2060 in wet season and also in dry season. So we can remark in the same year there is no big difference in 2020 between wet season and dry season, comparing to the difference between the 2 seasons in 2060. We can remark also that 62% of samples will be affected by seawater intrusion in 2060. since the depth from the ground surface to the water table is one of the most important parameters in vulnerability assessment. So the scenario also showed here are based on water level. To conclude, the degree of groundwater vulnerability varies depending on the climate change variability and is strongly impacted by seasonal variation in groundwater recharge. The results from the GALDIT method provide a good insight into groundwater vulnerability to seawater intrusion of the Ouz Jaghar al-Malh coastal area. And also the decreasing groundwater recharge will negatively impact the groundwater level and consequently increase the groundwater vulnerability to seawater intrusion, highlighted by the decrease of groundwater fluid discharge to the sea, as indicated by GALDIT. So this research did not consider impact of the evolution of human activities on seawater intrusion. However, future research will combine these results with other models to provide a useful tool to assess the vulnerability of groundwater to both contamination from sources on the ground surface and seawater intrusion for the shallow coastal aquifer under the future climate change conditions. Thank you.
Thanks, Salsabil, for your presentation about the GALDIT Vulnerability Index and the scenario that gave to you the opportunity to check the groundwater vulnerability. Now it is the last presentation.
Leila,
I will. Yes.
you hear me?
Yes, yes.
Okay, to continue, just I want to highlight that this study is conducted under in the framework of project Smart IWRM Majorda project. It's a project funded by peer program USAID. The project conducted between IZIM and US Geological Survey. About this project aim mainly to evaluate the availability and quality of water resources under climatic and anthropogenic stress in the lower valley of Majorda. Just my remark. Thanks, Leila.
Thanks to you also. So now we will go to the last but not least presentation of Madame Jamila Bensouissi about the impacts of global warming, acidification, and sea level rise on marine biodiversity and fisheries activities. Madame Jamila.
جست متحرش لازم نحدد لازم
جميلة عسلامة بنسويسي وين؟ جميلة
c'est bon. Alors, le partage d'écran.
Leïla?
Oui.
Est-ce que tu peux activer, s'il te plaît, le partage d'écran?
C'est bon, c'est fait. C'est fait qui le fait. Voilà, c'est fait. On voit maintenant votre présentation. Oui.
D'accord. OK. OK, est-ce que vous voyez ma présentation?
Oui. Oui, oui.
Oui, oui, Jamila.
Ouais. Je peux commencer?
Bien sûr, oui, allez-y, allez-y.
Good afternoon. Donc, first of all, I would like to thank Madame Tarhouni and Leila for their invitation to participate to this webinar.
I will give my presentation in French, but slides will be in English. La Méditerranée, donc comme vous le savez certainement tous, est considérée comme un hotspot de changement climatique. La Méditerranée donc, est considérée comme un hotspot de changement climatique et c'est l'une des régions les plus affectées par les effets du changement climatique, que ce soit donc en termes de réchauffement ou d'acidification. Et la Tunisie, avec sa position stratégique en Méditerranée, charnière entre les deux bassins, est particulièrement donc touchée par les effets du changement climatique. Nous avons procédé depuis quelques années à des suivis réguliers, notamment pour tout ce qui est température des eaux de surface, depuis donc la surface jusqu'à l'isobate moins 40 mètres, à l'aide donc de thermographes, donc c'est des dataloguaires que nous avons placés au niveau de l'aire marine protégée de Zembra. Et nous avons remarqué justement, grâce à ces suivis qui datent déjà depuis plus de 2 décennies, que les températures des eaux de surface de la Tunisie ont particulièrement donc, augmenté. Et que ce qui inquiète, c'est pas uniquement l'élévation de la température des eaux de surface, mais surtout donc la thermocline qui est de plus en plus profonde et l'apparition des vagues de chaleur à des profondeurs assez importantes, 20 mètres et plus. Et toutes ces données sont consignées dans le TMedNet, donc sont accessibles. Et c'est des mesures donc de toutes les heures depuis la surface jusqu'à moins 40 mètres de profondeur. Alors, les impacts de cette élévation de la température sur la biodiversité marine en Tunisie et en particulier sur les ressources d'intérêt halieutique sont énormes. Nous avons remarqué la profusion d'espèces dites thermophiles qui étaient quasiment absentes ou donc rarissimes sur les côtes tunisiennes, comme par exemple certaines espèces de poissons, Holopus filamentosus, le poisson lobote, le poisson perroquet, etc., qui actuellement sont devenus très fréquents et abondants et se vendent même dans le commerce, donc le marché. Donc, outre les espèces donc, thermophiles qui ne sont pas forcément exotiques, c'est-à-dire sont atlanto-méditerranéennes, on assiste à une modification profonde de la biodiversité marine tunisienne suite à l'occurrence de plus en plus importante d'espèces invasives, dites exotiques, dont la plupart deviennent invasives. Et sur ce graphe, vous voyez donc le nombre d'espèces non indigènes par décennie, donc depuis le début depuis donc 1900 jusqu'à 2010, et donc le rythme il va vraiment crescendo et pratiquement tous les groupes et tous les taxa sont concernés par ces modifications de la biodiversité et l'occurrence d'espèces donc qu'elles soient d'origine atlantique
ou de mer Rouge. Donc d'ailleurs, on parle maintenant de la tropicalisation des eaux tunisiennes. Donc chaque fois qu'on fait des prospections, on est confronté à de nouvelles occurrences et ces espèces constituent une véritable menace pour la biodiversité locale et la ressource halieutique et sur la santé humaine parce que certaines espèces sont carrément toxiques. Pour certaines espèces, donc, au départ, elles étaient considérées comme de véritables catastrophes, mais avec le temps, elles se sont transformées en une sorte d'opportunité et sont actuellement exploitées à une échelle commerciale. Je cite à titre indicatif donc la sardine que vous voyez donc sur cette diapositive et qui est originaire donc de mer Rouge. Le consommateur tunisien est en train donc d'acheter de plus en plus d'espèces qui sont allochtones sans se rendre compte. Donc cette sardine, elle est de mer Rouge, on l'appelle d'ailleurs la chadine, et elle est de plus en plus pêchée, notamment dans la région nord de la Tunisie, côté Rar el Mellah, etc. Et donc, selon une étude qui a été récemment menée, d'ici donc 2050, la moitié de la biodiversité existant au niveau du golfe de Gabès aura donc une origine exotique. Je voudrais focaliser sur un cas particulier, celui donc du crabe bleu, Portunus senis. D'ailleurs, actuellement, on a deux espèces de crabes bleus qui ont envahi les côtes tunisiennes. Donc, une espèce américaine, donc Calinectes sapidus, et l'autre espèce donc de mer Rouge, Portunus senis, qui a colonisé l'ensemble du golfe de Gabès et a carrément handicapé donc l'activité de pêche artisanale en colmatant les filets des pêcheurs et également donc en dommageant les captures. Voici quelques illustrations des dégâts qui sont occasionnés aussi bien pour les filets des pêcheurs que pour les poissons qui sont maillés en même temps que le crabe bleu dans les filets. Selon donc une étude que nous avons réalisée à l'échelle, donc c'est une initiative méditerranéenne, donc c'est des enquêtes qui ont été menées un peu partout en Méditerranée, et les pêcheurs, par exemple, tunisiens qui ont été interrogés sur la question du changement climatique et des impacts. D'ailleurs, on a pris des pêcheurs qui ont plus que 50 ans et qui ont donc une grande expérience professionnelle. Ils ont remarqué que les captures sont en train de changer avec donc une abondance de certaines espèces nouvelles et la régression de certaines espèces natives comme par exemple les mérous et autres. Et d'ailleurs, l'occurrence du crabe bleu a été à l'origine d'une véritable dynamique au niveau du golfe de Gabès. Actuellement, on compte plus d'une quinzaine d'unités de transformation de ce produit qui est essentiellement donc destiné à l'exportation. Donc, Les effets du changement climatique sont déjà perceptibles sur la ressource au niveau des côtes tunisiennes et surtout pour la ressource pélagique où on a assisté au cours des dernières décennies à des changements, par exemple de migration, de trajectoire de migration pour les gros pélagiques comme les tonidés. D'ailleurs, il y a quelques années, la principale technique pour la capture de ces poissons, c'était les madragues, la madrague de Sidi Daoud, celle de Capesbib et celle de Monassir. Donc, ces madragues ont été progressivement abandonnées et remplacées par d'autres techniques. Donc, parce que ce poisson ne passe plus par les mêmes endroits à la même période de l'année, etc. Donc, et actuellement, donc, ces poissons sont essentiellement détectés, les bancs sont détectés par satellite et capturés par d'autres engins tels que la scène tournante et coulissante. Alors, pour ce qui est de l'acidification, donc pour l'acidification, il est vraiment très difficile de dissocier donc l'acidification de l'eau de mer qui est liée à des actions donc anthropiques autres que le changement climatique. C'est notamment lié à la pollution et c'est pour ça que nous avons pris en considération uniquement ce que nous avons observé au niveau des aires marines protégées où il n'y a quasiment pas de pression anthropique, donc où on peut vraiment voir l'impact lié à la fois au réchauffement et à l'acidification. On a remarqué malheureusement que on assiste de plus en plus à des blanchissements de coraux. Autre chose, donc, c'est l'occurrence de phénomènes extrêmes ou d'événements particuliers, notamment donc la prolifération de méduses. Eh bien, on a de plus en plus au niveau des côtes tunisiennes de prolifération et d'occurrence de blooms de plusieurs espèces de macroplancton gélatineux. D'ailleurs, dans ce contexte, il y a un programme régional, le Jelly Watch. C'est un programme qui est initié par la Commission internationale pour l'exploration scientifique de la Méditerranée. Et selon les données hebdomadaires qu'on a pu récolter concernant la prolifération des méduses, il s'est avéré que la Tunisie constitue un véritable carrefour pour donc le passage de ces méduses dont quelques espèces constituent donc une menace pour non seulement pour la santé humaine mais également pour certaines activités comme le tourisme, l'aquaculture et autres. D'ailleurs, ces blooms de méduses ont également un impact important sur la ressource halieutique puisque plusieurs espèces de méduses se nourrissent au détriment des œufs et de larves de poissons donc, qui sont exploitables à une échelle halieutique. Donc, la Tunisie, comme vous le savez, donc, pour la Tunisie, l'activité de pêche est très, très importante. Donc, la pêche, elle joue un rôle clé dans l'économie du pays. Donc, avec plus de 2000 km de côte, avec une infrastructure portuaire très importante, plus d'une quarantaine de ports, avec une production annuelle qui dépasse les 100 000 tonnes. D'ailleurs, le secteur de la pêche, il contribue à la sécurité alimentaire avec 11 kilogrammes par personne et par année, et il procure plus de 100 000 emplois directs. Donc, en plus des impacts sur la biodiversité et la ressource, donc, le changement climatique a lourdement impacté le secteur de la pêche, et une étude que nous avons menée a révélé que les pêcheurs et les aquaculteurs ont généralement une perception qui est bonne, donc qui est assez fiable de ce que c'est que le changement climatique comparativement à d'autres actions anthropiques comme la pollution et autres. Donc, une étude fine que nous avons réalisée avec le concours de la FAO a montré que les côtes tunisiennes sont pas, enfin, l'activité de pêche et de l'aquaculture en Tunisie sont particulièrement vulnérables donc au changement climatique, et que c'est le golfe de Gabès qui est la zone la plus touchée et la plus vulnérable donc à ce changement climatique. Et plus précisément, donc bon, il y a la pêche côtière, et parmi donc les activités de pêche côtière, donc on compte la pêche au shrafi, qui est une technique respectueuse de l'environnement. C'est des installations fixes à partir donc de branches de palmiers. C'est une technique très très ancienne et ces installations fixes donc sont actuellement fortement menacées par l'élévation du niveau de la mer. D'ailleurs, là, vous avez sur cette figure donc la répartition des pêcheries fixes au niveau donc de l'archipel des Kerkena. Donc, ça constitue l'essentiel de l'activité de pêche dans la région. Et que avec donc ce que vous voyez sur cette figure, donc c'est l'aire de distribution donc de l'activité, donc de répartition de l'activité ou d'installation des pêcheries fixes, qui est de l'ordre de 80 000 hectares, mais dans le cas où il y aurait une élévation donc de 1 mètre du niveau de la mer, malheureusement, l'essentiel l'essentiel donc de l'aire de répartition, elle sera plus disponible, et elle sera réduite à 7 000 hectares, parce que justement on ne peut installer ces pêcheries fixes que dans les zones de haut fond, parce qu'on est limité par la longueur des branches de palmiers. L'autre activité qui risque donc qui commence déjà à percevoir les contre-coups du changement climatique, c'est la collecte des palourdes. Donc c'est une activité qui est exercée essentiellement par des femmes, qui procure plus que 6 000 emplois. Donc, cette activité, elle se fait au niveau de l'estran, c'est-à-dire à la zone de balancement de marée, mais avec l'élévation donc du niveau de la mer, avec surtout les problèmes sanitaires qui sont liés à l'occurrence donc de plumes de microalgues toxiques. Cette activité va malheureusement considérablement régresser, et donc les revenus de ces familles donc de collecteurs vont être donc fortement diminués. Voilà, donc là, c'est justement c'est la zone intertidale, c'est la zone, lorsque la mer se retire, les femmes donc exploitent cette frange du littoral pour repérer et récolter donc la palourde ou la clovis qu'on appelle communément en Tunisie. Donc, à partir de ces quelques exemples, donc j'ai montré que la pêche artisanale en Tunisie, qui est donc l'essentiel de l'activité de pêche dans le pays et plus particulièrement dans le golfe de Gapès, va subir et va être donc le siège de fortes menaces face au changement climatique. Voilà, donc je vous remercie pour votre attention.
Merci Jamila pour la bonne présentation. Laïla. Laïla. Laïla.
Laila, we can hear you. I can see you have opened the microphone, but we cannot hear you.
You hear me, Jamila? Yes?
Yes, yes, yes.
But Layla, no. Huh?
Layla, she has a problem in her phone, in her micro. So,
shall we continue the discussion, please?
Yes.
Yes, go on, Faye, please.
Okay. I don't know. I think it's the whole presentation have finished now. From what I can see in the agenda, so it's the discussion. And if somebody wants to place a question in the chat or directly, we can do that.
Maybe just one comment, if you...
Yes, of course.
Just to say there is a link between land and the sea. And in my presentation, I didn't speak about the effect of land degradation and freshwater contamination on the sea, mainly for the availability for plankton, and this is also main issue. It can accelerate the degradation of the in the sea, and there is a narrow link between land and sea also. Okay.
Can I
Jamila, now we speak about the continuum. Now,
yes, Jamila.
Yeah, yes. So no separation between the coastal area, land coastal area, and the sea. So
yes, I'm agree with you, Jamil.
It is considered as a part of littoral, and we speak about continuum.
Yes, this is why I made this comment, because to see it's not disconnected. It is unique place, and we should consider all together. Thank you.
Jamila, it's deeply connected.
Yes, thank you. I know. Yes.
Can I tell something?
Yes.
I want to speak about coastal erosion as usual, because I think it's an important problem for Mediterranean countries. It's a phenomena which is more and more deep and important. So I think that we have to study it with many specialized on the field, GIS, hydrogeologic modelization. That's all.
I think from all the factors in coastal area, the coastal erosion is the most important, because it is very huge problem, and also we can get very rapid change in time and in space.
Yes, and the most visible phenomena.
Yes, I'm agree.
I would like also to add that I come from the island of Crete in Greece, and I can see that everything that you have been presenting for Tunisia looks so familiar in that environment about the diversity of the species of fish, for example, and also the beaches that are transforming. So I can see many similarities, and it's actually that demonstrates that it's a common problem now in the Mediterranean area.
I have a question. I am Riccardo from Italy. Can I ask to the marine specialist if they have seen, with the increase of temperature of the water, of marine water temperature, an increase also or a decrease of the production of Posidonia oceanica in the Mediterranean Sea?
For the Posidonia, I think it's most of the well-adapted species to climate change, because this phanerogam has developed a strategy against climate change, such as for example, for the reproduction of the species, the fructification and florism of the species is changed during the last decades. So I think for Posidonia, no problem. It's well adapted endemic species for the rise of for the increase of temperature.
Thank you.
We do have a question in the chat from Sabrine Sahbeni. She's asking how to separate between effects of climate change and anthropogenic pressures.
Can I answer?
Yes, of course.
Some element for answer. I will say simply it is difficult to separate, because the effects are overlaid, and one will accelerate the other, and it is really difficult. We can analyze the effect of temperature alone. We can analyze the effect of seawater level rise alone, but the final results is the result of the interaction of the factors, land factor and also marine factors. Okay, and the problem is very, very complex, and we should make many analyses and combined analysis. Thank you.
I agree that it is very difficult to separate the effects of of anthropogenic pressures and climate change effects, for example, in the sea. But in our case, we decided to use the marine protected area, because in this special protected area, for example, we have no major pollution, no overfishing activities or fishing activities in general, or pollution, illegal fishing, etc.
As a reference zone.
Yes, at Mediterranean scale.
Yes,
because in other area, it is impossible to separate the different effects.
Yes.
Because we have all the activities in the same types.
I agree. Yes.
Other questions, please?
Yes, Leila, finish or still have
It seems
more
that there is no more questions. Yes. So thank you a lot for your collaboration, for this
Did you get
interesting
all
presentation.
Leila, please, did you get all the presentation to share with
Yes, I will get them. I've sent an email to get them. Yes.
Okay, bye-bye. Thank you very much.
Thanks.
Thank you very much.
Thank you for your.
Thank you. Bye-bye.